All right, hello everyone. This is Mr. Stewart and Miss Adams here. We're going to be working on coming up with a simple class as an example and also show some paired programming.
So when you're pair programming on Zoom, the first thing you're going to want to do is share your screen. So whoever is in charge of sharing their screen with their partner, you're going to click on the green share screen icon. And when you do that, it's going to give you a bunch of options for what to share. You want to choose desktop. So that will let you share all of the windows and apps that you have open on your computer. And then you just click share. And I'm going to go to processing. So now both Mr. Stewart and I can see the processing program that I have open.
Yep. So as you can see, we are working on making a basic car class. So the cars will have a position and speed. And in terms of actions, we're going to start with just moving them to the right. Once we've got that working, we're going to add an extension where we can instead use the arrow keys and control which direction the car is moving.
All right, so Mr. Stewart, what do you think we should do first?
So we've started off with just a basic setup and draw. So the very first thing we're going to need to do is we're going to create our car class and then start thinking about what different things we're going to need within that class. So to make a new class, we can make a new tab using the arrow just to the right of where it says Sketch 2004. Your file is going to match the name of your class, and whenever you're talking about classes, you always use uppercase capital letters for the class itself. So this would be car with a capital C.
Okay.
To begin a class, you say the word class, and then the name of the class, so in this case car, and then we put a set of curly braces around our entire class. So what a class is doing is defining what exactly it takes to make a car. So we're going to have attributes associated with this class. So if we think about what it takes to make a car, we have two things that are given in the objectives. We need to know the direction of the car, we need a speed for the car, and then we also need a position. So we're going to start with two variables or attributes for our class to go with any car. So and they should both probably be integers, so we'll have an integer for position and we'll have an integer for speed. Now, so that's basically giving us, now we can make different cars that have those two attributes associated with them. The next thing we're going to need to be able to do is to actually create different cars. The way that we do this is with a method called a constructor. So to do that, we make a new method that would be, most likely it's going to be a void method because we don't need to return anything. So it would be a void car. So the name of the constructor matches the name of the class. And we'll need parameters for this, so we put parentheses. And we're going to need, in this case, we probably need to know the starting position and the starting speed for those. So we're going to add two variables. Like so. So these are now parameters that tell us when we make a new car, that's where it's starting and that's the speed it's starting at. So we will now add some curly braces to this method, and inside we will just say that our general attribute for the class position is going to be equal to the start position. And our speed is going to be equal to the start speed. So the next thing is let's actually look at just making a car so that we can get a sense of what that looks like in terms of our main function. So if we go back to our main function, to use that constructor that we just made, we would, as a global variable at the top of the code before setup, we are going to add a new car. So we are going to call the class that we just made, car with a capital C. And now we need to come up with a name for our car. So when you name your cars, it's just like you're naming a variable. And let's say that we have two different cars to start off with. So in that case, we need to come up with names for our cars. So we could just call them car 1 and car 2 as a very simple thing. These are called objects. So these are specific instances of our cars. And because they are specific cars or objects, we use lowercase letters instead of uppercase letters. So you can see car 1 and car 2 both start with lowercase c's. So to actually make these cars, we're going to need to use the new operator. So within setup, we can add a line that says car 1 equals new, and then we'll call the car constructor by using capital C in car, and then in the parentheses, we need to specify its starting position and starting speed. So let's go ahead and put it at the, let's say 101. Now, immediately as we're talking through this, there's an issue coming up. So, Ms. Adams, do you see the issue?
Well, I'm wondering if when you say let's put it at 100, are you talking about on the x-axis or the y-axis?
Exactly. So when we are specifying the position, we're going to need to know both a starting x and a starting y. So maybe so let's go ahead and make a small revision to our car class. So instead of having just position, let's make it x and y, and then we'll have to modify our constructor to match. So we'll have int x and y.
Okay, so I'll add a second field.
And then we'll have a start x position and a start y position.
Okay, and then I'll change the code in the constructor as well.
And notice again, when we're using these fields and when we're using these parameters, so there's a lot of different terminology that basically means they're all different types of variables. So the fields are associated with the entire class. The parameters are associated with the individual methods. So start x position, for instance, is a parameter. So that should now work. And so back in our main code, we're going to have to modify, when we make a new car, we need to give it both a starting x and a starting y. So Ms. Adams, if you want to pick values for both start x and start y.
Okay, so let's make 100 be our x position, and then for our y, let's put it at maybe 200, so it's right in the middle, and then our speed could be 1.
Okay, and then we'll need to also have a second car, so we'll make car 2 equals another new car. And why don't we start this also at 100, but we'll start it further down the screen, so let's make it at 400. And let's give it a faster speed. So let's make it 400 for our starting y position, and then let's make it 2 for our speed.
Okay. I'm wondering, with our height being 400, is our second car going to show up on our screen?
That's a good point. It depends on how big the car is, but it would probably be better to either make our window slightly bigger or move car 2 up. Good point, Ms. Adams.
Okay, let's move it up to 300 to make sure it's on our screen.
So we now have our cars created, and we need to actually do something with those cars. So we're going to add some methods to the car class. So the things that we're definitely going to need to be able to do would be to both be able to draw a car so that we can actually see the cars on the screen, and we also will be able to need to be able to move the car using that speed. So if we add a new method, we would call it void draw car. And in this case, we will not need any parameters because the fields associated with the class are going to be accessible to any of these methods in the class. So inside of here, we're going to need to just draw a shape representing our car. For the sake of simplicity, why don't we just start off by making it a rectangle? And then one of the things we could do to make it a more realistic looking car is to give it kind of more of a car shape. So we already know our position, so we're going to draw the rectangle at X position, comma Y position. And then we'll need to give it a size. So we could put in some numbers here. We could also add a field to our class that specifies the size.
Let's start with keeping it simple and just have all our cars be the same size, and then as an extension, maybe we could add the size.
Sounds great. So what if we made it 100 pixels long and 50 pixels tall?
Okay.
So now we have a way to draw a car. It's going to be very blocky, and we also need to be able to move the car.
Okay, so let's add another function for moving.
So we're going to add void move car, and again, because we're just using the fields of the class, we don't need to worry about adding parameters here. So when we're moving the car, we're going to be using the speed to change our position. And we started off with our objective by saying we're just going to move the car to the right. So we're going to take our X position as our starting variable, and we're going to add to it the speed. And so this may not be the same for the two different cars. That's why we're using the objects of the cars will have different speeds, and they may also have different positions. So we've got our methods made, pretty straightforward. And now over in our main class, we need to actually use those methods. So in draw, we're going to be updating every frame. We want to both move the cars and draw them again. So we're going to do that for both car 1 and car 2. Now, Ms. Adams, does it matter the order in which we move and draw them?
No, I don't think so, because if I remember right, the draw function runs all the code and then updates the screen. So we can tell it to move car 1 or car 2 first, but it won't draw them until all the code is run.
So that's correct, but we should also think about whether we want to draw the car, within this, whether we want to call our draw car method first and then move the car, or move the car and then draw the car.
Oh, so you're saying for each individual car, we need to think about the order that we're calling methods for that car.
Correct. So I think why don't we go ahead and draw the car and then move it for the next frame?
Okay.
You can do this either way, but so for instance, car 1, we would do car 1 dot move draw car. So that draws it at its starting position, and then every frame it'll draw it again. And then afterwards, we'll do car 1 dot move car to move car 1 along.
So we won't actually see the movement until the next time that we run the draw function and it draws it at that new spot.
Correct. And then we will do the same thing for car 2. So we'll draw the car and move the car. And it would be reasonable to do these in the other order, but you should think about the order that you're doing them. Ms. Adams, we need to move the car for car 2.
Oh, thank you.
Okay, so now we should actually be able to run this and see two rectangles moving along the screen.
Oh, it looks like we have an error, and it says the constructor is undefined. So maybe we need to check our constructor for our car class.
Yes, so currently we have 3 parameters, and saying for 3 integers, it's undefined. So if we look up,
so we wanted this to be our constructor, but we put void in front of it.
So we need to instead return an object of car type.
So if we just put car, then maybe it'll recognize it as our car constructor, since constructors don't have return types.
All right.
Let's try that and see if it works.
So we've got our cars moving. So we have a bug going on, which is that our cars they keep leaving the old cars on the screen and not moving the car. So we're going to need to get rid of the previous drawings every time. And the easiest way to do that is to use our background function, within void draw. So in void draw, at the very start of draw, we're going to call background and use that to get rid of the previous frames. So we're going to just specify a value for our background color. If we use 255, it'll make it a white screen. So that's probably a good place to start. And now if we run that, there we go.
All right, and we can see our bottom car was faster because we had the speed of 2 for our second car.
All right, so we're going to end our paired programming demo here, and then we'll talk through the key presses.
All right, so now that we're done with our pair programming example, we're going to show you how we implemented the extensions so that we can use the arrow keys to move car 1. So the first thing we need to do was go into our car class and add some functions so that we can move more than just to the right. So before we had a function called move car and it just moved our car to the right. But now we want to be able to move in all directions using the arrow keys. So we changed that move car to be called move right. So we're still adding speed to our X position. Then we added some functions, move left, so we're decreasing our X position by the speed, move up, we're decreasing our Y position, and move down, we increase our Y position. So now we can use those 4 functions that we put in our car class to actually move the car when we press on the arrow keys.
So in order to actually do that, we've updated draw to have car 2 always moving right, as you can see, instead of just moving car. And we had to add a function called ProcessInput that looks at our arrow keys. So if we look at the code there, the first thing we're doing is checking to see if there is a key pressed. So while you're holding the key down, any key down, it'll say, okay, a key is being pressed right now. Then we check to see if a key is coded. The normal letters on the keyboard are not coded. You can directly use if the key is equal to A, B, C, whatever letter. If you're using the arrow keys, those are special keys, so we have to use this key equals coded and then check the individual key codes. So for instance, if the key is coded, meaning it's one of our special coded keys, such as the right key, we'll check and see if that key code is right, we move the car right. If the key code is left, we move the car left. And similarly for the up and down key codes. So when we do this, every time we run through draw, it's going to check and see if there's a key being held. And if so, if it's one of our arrow keys, it'll move the car in that direction, car 1.
So we'll go ahead and demonstrate this now. You'll still see car 2 at the bottom moving to the right, but car 1 is just going to sit there until we press a key on the keyboard. So this is car 1 right here, and I'm going to press the up arrow key, so our if key pressed is going to become true, and our car does move up and then down and right and left. So those are just the different if statements firing as we press the keys.
It makes parallel parking a breeze. All right, thank you, everyone.
All right.
Thanks, Adams.
Thank you, Mr. Stewart.